And I'm going to tell you which ones correspond to free response questions on your test. So the free response ones are 6A, hold on one second, 10, 11, and 16. Oh, okay. So those are the ones that correspond to, like, you know how I make them sibling problems, like kind of as hard as I can to tell you your test had them. Those are the ones that are going to be like free response questions. All right. So number one, for a differentiable function, f of 2 equals -3. Here's what I would do is I would just draw a quick sketch of that. 2, -3. I know that point is right here. A picture is worth an infinite number of words, just to give you a visual. So that point would be right here. All right, it says f of 7 also equals -3. So that point's right there. You should already be thinking some things. Like, what does that tell you already? Or like, what do you notice? Well, all lines are straight, but specifically what kind of line? Horizontal, zero slope. Are you thinking zero slope already? That's where your brain should be. You should be like, oh, I know some things about that, okay? And then the other point is 5, 4. Now they said that the function was differentiable. That means it is also continuous. We don't have any breaks, holes, gaps, jumps, asymptotes, none of that. It's going to connect. All right. So let's go through these and we're just going to say yes or no. Does the function have any zeros? Yes, because it's going to have to go through. How many at least would it have to have? It has to have at least 2, because if you connect these, now, do you get that it could have more? Like it could go up here and go through a bunch of times, and then, do you get what I'm saying? But at least 2. Okay, so yes, and at least 2. Does the function have a horizontal tangent line? I tried as hard as I could to lead you towards that one before we even started. Horizontal's this way, guys. What do you think? Yes. Look, if you connect it, do you see how there would be a horizontal tangent? That's also Rolle's theorem, because remember, if it starts where it ends. Hello? Okay, so yes. Does the function equal 2 at some point on the interval? Yes, because if you connect these, aren't you going to go through 2? Does the function equal 6 at some point? I like that you said maybe. It could, because the graph could go up here, go through 6 and come back, but is it guaranteed? No. Okay, so we're going to say no to that one. It isn't guaranteed, but it's like a maybe. I love that you said maybe though, because people will be like, no. And I'm like, well, it might. You can't guarantee it. All right, find the value of C guaranteed by mean value theorem, blah, blah, blah. Mean means average. Average rate of change means slope. Okay, so we need a point, -4 comma something, -2 comma something, and we're going to slope them. So if you plug in -4, -4 cubed, right, -64, -2 times -4 be +8. So that would be -6. Good. All right, if you plug in -2, -2 cubed, -8, and then that would be +4. So -4. Wow, they're all negative, so be really careful here. When you go to do your slope, -4 plus 56 over -2 plus 4. So that would give you 52 over 2, 26. Good. Okay, so we're like halfway there. Not the equation, but the derivative. Okay, you have to find the derivative. Its average rate of change equals instantaneous rate of change. So what's your derivative of this guy? Yep, good. 3x squared minus 2, set that equal to 26. The common mistake is people set it equal to 0, and I totally get why that happens, because we do critical points so much. Try to remember to set it equal to whatever number you get. From there, you're just going to solve. All right, so what next? Welcome back to algebra. I would do +2. So you would get 3x squared equals 28. Then what? All right, divide by 3. 28 will not divide by 3, so I'm just gonna leave it as 28 over 3. And then square root. Now, usually you put what in front of a square root? Plus or minus, but look at your interval. It's only gonna be the negative one. So negative square root of 28/3. Because it has to be on your interval. Good, well remembered. All right, number 3 is sort of like number 1. For a differentiable function, and again, if it's differentiable, that means it is also continuous, all right? I would just draw a quick sketch. F of 1 is 5. You're right there. And 4 gives you 8. That's not required. You don't have to. In fact, there's no work at all required for multiple choice. You could technically put C for everything. I don't recommend that. All right, but I think the visual helps. All right, and when because the function is continuous, when you connect those, you're going to get all the points in between. So it's intermediate value theorem. Does the function have to equal 7 at some point? Yeah. Yes, because 7 is in between 5 and 8. So we have to get that. Does the function have to equal 1? Not necessarily. It could, but we're not guaranteed that. Now, C and D are a mean value theorem. You're going to have to slope these and see if the instantaneous rate of change equals the average rate of change. So you would have to do 8 minus 5 over 4 minus 1. Or I guess if you already drew it, you could just count the little boxes like you did in Algebra 1, how much up and how much over did it go? But that would be 3 over 3, which is 1. So letter C, does the derivative equal 1 at some point? Yes, because we got 1. Does it necessarily have to equal 0? No. Okay, it's just what you're guaranteed. Cool, this is going well. You guys are getting this. Awesome. All right, absolute. What is your test for absolute maximums and minimums? What do we call that test? Candidates. Who are your candidates? And I'm looking for a word, not a number. Yeah, endpoints, which are these critical points. We have to do derivative equals 0. All right, so what rule do we need for this derivative? We're reviewing our rules. Power rule and chain rule. Good. You're going to bring the 3 down. It'll drop to a 2. That's your power rule. The guts of it is going to stay the same. And then you chain on the derivative of that stuff. So that would be 4x plus 4. And we're going to set it equal to 0 for critical points. I'm going to verbally just talk you through a little bit of this so we can do less writing. What's 0 divided by 3? 0. So you don't need this. Ignore that. And what's the square root of 0? Still 0. So you don't need that either. Okay. You're just going to set these two things equal to 0, factor them and solve them. All right. So if we do this first one, what can you factor out of that? We're just going to do them separately. All right. So take out 2x. That would leave you with x plus 2. And so the two answers you get out of that, 0 and -2. Good. 0 is a really nice number because it makes a lot of stuff go away. Now, if you set this other factor equal to 0, you would subtract 4 and then divide by 4. So you would get -1. Perfect. So then you make your table. And you're going to need to do your end points, which are -3 and 2, and then your critical points. Now, occasionally, one of the critical points goes outside of the interval and you get to toss it, which I always like when that happens because it's less work. I think we actually have to keep all of these though, don't we? Yeah, unfortunately. Now you can put them on there in whatever order you want. I like to try and keep them, you know, in numeric order. You're plugging them into what though? If you accidentally plug them into the derivative, you will likely catch it. Because you will get 0 for all. You're gonna be like, wow, these are all coming out to be 0. And then you're gonna be like, oh, I should have plugged it into the original. All right, so if you plug in 0, I'm gonna just hop to that one first because I think it'll be easiest. The whole thing will be 0. That's kind of nice. All right, -3. -3 squared. 9, double that, 18. And then you would have -12. 18 minus 12, 6 cubed. I know that that's 216 just because I'm a math teacher, but there's nothing wrong with 6 cubed. So do that. All right, -2. -2 squared. 4, double that is 8. And then it would be minus 8, so 0. Negative 1 squared would be 1 times 2 is 2. Minus 4, 2 minus 4, negative 2 cubed, negative 8. And then lastly 2. 2 squared is 4 times 2, 8. Plus 8 would be 16 cubed, which I don't know that off the top of my head. A large number. All right, so what's the absolute maximum? Yeah, absolute maximum is 16 cubed, whatever that is, at x equals 2. And then what's the smallest number we got? Negative 8, good. At x equals negative 1. It'll be multiple choice, but if you had to justify, the justification is the table. Perfect. I love that. All right, we'll do number 5 and then we'll do a break. That'll be a good place for a break because I heard the bell ring there. All right, at what value of k, so find k, that's your goal, does this function have a critical point? So you need to know what critical point means. That means derivative equals 0. Okay, so let's find our derivative, set it equal to 0. I didn't really read through it, but I think we're going to need some rules here. What rule are we going to use first? There will be a chain rule, but first is going to be product. The first thing is 2x. The second thing is e to the stuff. I like this. We're reviewing all our rules. How does product rule start? All right, the first thing, so 2x. Derivative of the second. All right, that would be itself. And then you would chain on the derivative of kx. What would that be? Good. It's like the derivative of 3x is 3. The derivative of kx, k. All right, so it's going to be k e to the kx. It's like the alphabet threw up on your paper. All right, plus. So it's first times derivative of the second plus the second thing times derivative of the first, which would just be 2, equals 0. I realize that looks awful. I know, I'm with you. What do they share in common though? Because it's really only 2 terms. It's really just this plus this. What do they both have? Yeah, a 2, good, and e to the kx. So we're going to factor that out. And I promise after we do that, it will look a lot better. You're going to be like, oh, okay, this won't be so bad. So if you take out 2e to the kx, what's left from the first part? Just x. Can I put kx? Just because k is going to be a number, and usually we do like 2x or 5x or 7x, so we'll say kx. All right, plus 1. If you take the whole thing, it's 1. Now come with me on this. Exponential, which is my favorite one, looks like what shape? I call it a swoop. It has an asymptote at 0. Will it ever touch 0? No. No. This will never equal 0, so it does not give you anything. I told you it was going to look a lot better. So all we have is kx plus 1 equals 0. What was x? Go back to the original problem. X is a half. You're going to plug in a half for x and then solve it for k, and that will be your answer. The derivative was tough. It involved a product rule and a chain rule. It looked a little messy, but I don't think it was too terrible. What would you do to start solving? All right, minus 1 times 2. K is negative 2. So we'll do our little 3-minute break right there. I do want to be able to finish the whole study guide though. So just like a quick 3-minute break and then we'll keep going. So this one is very much like the delta math that you did. What are you given? Graph of f prime. Y'all have your sticky note handy? All right. And you can't use your sticky note on the test. You're going to have to write it. All right. I would write it right at the top of the test, like first thing when you get it. All right. So you're looking at f prime. And 6a is one of the free response ones. You're going to have to justify it. So look here. On what intervals is f, the graph you're not looking at, decreasing and concave up? Watch me point to it. Decreasing is right here. Concave up is right here. That means the graph you're looking at needs to be negative. That means below sea level. Are you paying attention there? I want to say your name because I'm recording this. Below sea level and Increasing. All right, can you find places on this graph where it is below sea level and also increasing? All right, -2 to -1 is the first one. I'm going to start all the way over here because we do have to justify this. -2 to -1, union, where else? 2 to 3, good. Below the x-axis and increasing. All right, so that's your answer because who's your source? What's the thing you have? F prime. You have to cite the graph you've got, all right? Because F prime is what? Negative and increasing there. It's a point for the intervals and a point for the reason. It's usually how they do them. And it all comes from this. Fantastic. I love when they ask those on the AP exam. All right, B, that's going to be a multiple choice one, so we can just, say the answer. On what intervals is F increasing? Look at F is increasing where the graph you're looking at is positive. That means above sea level. All right, so that is from, this is going to keep waving. So I guess it would be -4 to -3, or no, sorry, I guess that would be -5 to negative. You know what? Let's just not do that part. Let's start here. Where is it above sea level? Let's just say -1 to 1. I realize it's going to keep going, but it goes off the picture. So we'll just say that part above sea level. All right, number 7. I kind of put 7 and 8 together a little bit, made them sort of piggyback on each other. Draw a graph where? What on earth does that mean? Derivative, first derivative is negative. All right, where the first derivative is negative means your graph is, okay, hold that in your mind, decreasing. What does this mean? Second derivative is negative. So look at concave down. So we want to be decreasing and concave down. That would look like this. Going down and it's bending down, decreasing and concave down. It's headed downwards in a speeding up kind of way. If you think about velocity and acceleration, do you remember if you jump out of an airplane before you pull the parachute, you have negative velocity and negative acceleration, speeding up in the negative direction? Okay, so look at this one. I made them the same. Decreasing, concave down, f of 2 equals -1, f of 3 equals -4. So look, when you go from 2 to 3, from x being 2 to x being 3, how much did you subtract? You subtracted 3. Are you still with me? Bless you. So what could be f of 4? When you get to the next point, you have to subtract more than 3. Do you get what I'm saying? 3 is not enough because you're going down in an increasing way. So subtracting 3 is not enough. You have to subtract more than 3. So from -4, if you subtract 3, -7, not good enough. It needs to be -8 or less. You could subtract more, but you have to subtract more than 3. It's decreasing faster, faster. Think of jumping out of an airplane. Okay. All right, what are you given for number 9? Double prime, second derivative, and you get asked about inflection points. So you don't need to take a derivative. It already is the second derivative, which gives you inflection points. There is a little bit of a twist to it though, so I want to see if you can give me the answers. Where would there be inflection points? X equals what? 1, good. That's it. Why don't we count this one? It's squared, and that means it stays positive and there's not a change. Do you remember for inflection points, there has to be a change? So that one doesn't count. It will just be these two. But you'll get it right on the test, right? Because I just went over it. All right. Where is this graph concave up? Which derivative do you need for concavity? Second. Okay. Well, unfortunately, we can't jump straight to the second derivative. So we're going to do the first derivative first. What rule do you need? Product. All right. First thing, which is -x. Derivative of the second, which is just e to the x. All right. Plus the second thing. What would be the derivative of -x? -1. Can I just erase this plus and make it a minus? Is that okay with everybody? All right. Second derivative. You're gonna need product rule for this. And then you'll have to take the derivative of that part separately, okay? So it is gonna be, I'm gonna cover this up. It's gonna be first thing times derivative of the second. Yeah, no, it's a lot of repetition here because e is the derivative of e to the x is e to the x, so it becomes very repetitious. All right, first times derivative of the second plus second times derivative of the first. So yeah, again, I'm just going to change that to a negative. So that was our product rule. Now I'm going to take my thumb off of this. What's your derivative of minus e to the x? Yeah, exactly. And we're going to set this equal to 0. We're looking for inflection points. Yeah, those are some like terms there. If you see that, we've got negative x e to the x. But look at, this is minus e to the x and minus e to the x. That would be minus 2 e to the x. Good, I'm glad you noticed that because I was going to ask. And then what do you now notice? They both have got e to the x. Now, you could factor out a negative if you want. In this case, I'd probably leave it there. Or we could take it out. I don't know. What do you want to do? Do you want to take the negative out as well? You want to keep it? Okay, we'll just keep it there. All right, if you take out e to the x, you're left with negative x minus 2. Once again, what does e to the x look like? A swoop. Will it ever equal 0? No, because there's an asymptote. So you don't need this. You just need to solve the other part. So you would add 2 and then divide by a negative. So you're going to get negative 2. All right. So let's draw our number line. Hey, something weird happened. That's weird. Do you see how it starts with a negative? You're going to reverse it. Instead of being negative and turning positive, it's going to be positive, turn negative. At this point, I forgot what they were asking though. What were they asking? All right, concave up is where your second derivative is positive. So negative infinity to negative 2. Cool. All right. For the graph of, what are we given? F prime. They usually give you F prime. Do you have your sticky note handy? All right. Oh, I modeled this one after, I think I told you guys this, that there was one year where they put all these constant sections in it. And I was like, I know my class all missed that. And ever since then, I have like slammed this. I've hit this hard. I'm like, you're not going to miss it if they do this again. All right. Inflection points. Look at, that's where the graph changes concave up to concave down. That's where the graph you're looking at changes increasing, decreasing, or decreasing to increasing, but constant doesn't count. So I think there's only one. Where do we have an inflection point? Do you see that? -3 changes from increasing to decreasing. None of the rest of those count. I guarantee you my class missed that year. I was so mad. None of the rest of them count. Oh, justification. This is one of the free response ones. So you would say x equals -3 because f, if you say it, I can't give it to you. Please, I will have to write ac on your paper. Because f prime changes from what to what there? Increasing to decreasing there. Please don't write it. I don't remember if it was in here or I think it might have been my other class. Somebody said they took the quiz and then went back and erased all the its and changed them to f prime and f double prime. Do that. All right. Again, I'm going to try and save 12 and 16 for after the lunch. We'll go to 13. Oh, this is the fencing problem. There's 400 feet of fencing. You're going to make a rectangular pasture. One side is going to be against the lake. Why is that smart? Less fencing that you'd have to use. All right. So this is X. This is Y. Optimization. It's not a new concept. Maximums and minimums. It's just a word problem. You're taking what you know and applying it to a word problem. We need an equation for area because it says we want to maximize the area. So how do you do the area of a rectangle? Good. So area is X times Y. What's the matter with that? Why is that a problem? Two variables. So you go back to the problem. You're like, hey, there's 400 feet of fencing. Can you write me an equation involving that 400? Beautiful. This is like all algebra and like one step of calculus. Which variable is easier to isolate? X. X would be 400 minus 2y. You're going to plug that in for X. And then one more step before we do the derivative. I would distribute it so you don't have to do a product rule. And its derivative equals 0 because critical points are what give you the maximums and minimums. All right. So what is this derivative? A prime.
400 minus.
Good. Equals 0 for critical points. I'm going to talk you through it because I ran out of space. What would y have to be? You solve that. So you subtract over the 400, divide by -4. What's y going to be? 100? All right, let me put that in my picture. This is 100. This is 100. If you have 400 feet of fencing, X is 200. And your final answer for your area is you have to multiply those together. So 20,000 square feet. Good. But it'll be a nice number like that. All right, this one was kind of interesting. I didn't mind this problem so much. You are gonna have to draw a graph though. And I think I wanted to change this. Yeah, I'm really sorry. Can we change this? Can you make the 8 a 6? And can you make the 4 a 2? I was trying to make the problem less heinous. Okay, make it work out kind of nicely. All right, so we're gonna need to draw that. It's gonna be a parabola. Let's start by plugging in 0. If you plug in 0 for X, this whole part's gonna be 0. So good, 6 minus 0 is 6. We might just finish that one, this one, and have to break here for lunch, but stick with me. I know we're hungry, but like, gotta do all the problems. All right, then I would try to plug in some other numbers. Let's see, if I plug in 1, I'm gonna get a fraction. I think I tried to, no, you know what? Actually, it doesn't really matter what the other numbers turn out to. It's just gonna be an upside down parabola. Let's just do that. I was gonna try and plug in some numbers, but it doesn't really matter. We don't need it to be super specific. All right, so there's our graph. The lower 2 corners are on the x-axis. The upper 2 corners are on that graph. So what we've got is a rectangle that looks something like this. And it has to stay within those boundaries. What are we trying to maximize? Because that's the thing we need to write an equation for. Maximum area. Area is length times width. Watch me point to this. This amount is X. And this amount is Y. So just X times Y won't do it. It's good. Well, 2X times 1Y. Okay, so it's going to have to be 2XY. What's the problem with that? There's 2 variables. We're going to substitute in for Y. And do you see this convenient thing here? Y equals? You take all that and plug it in for Y. So it's going to be 2X times 6 minus X squared over 2. All right, then what? Distribute. It's almost exactly like the fencing problem that we just did. Bless you. So what would that give us? 12x minus. Cancel out the 2's, that's good. And then x times x squared, x cubed. Don't forget to do the most important step. Set what equal to 0? Derivative. Because people will set this equal to 0. That happens all the time. All right, derivative would be 12 minus 3x squared. And then just keep going. From here on out, it's algebra. You would subtract the 12. Oops, that'll be -12. And then divide by -3. So what's X? 2. If you're like, hey, what about plus and minus 2? Well, I mean, we're talking about the distance here. I guess you could say -2 went that way. But X is 2. Now we need Y. Just take 2 and plug it back in to the equation. 2 squared, 4. Divided by 2 would be 2. And then 6 minus 2 is 4. You just plug it back in. And so what's your area? Area was 2 times X times Y. So 2 times 2 is good, I agree, 16. And it would be units squared. It's just we don't have units for this because it was just, and I can do 15. And then all we'll have are the ones with parts to them when we come back. We can do it, we can do it, you can do it, I promise. All right, a line passes through the origin. That's actually a really convenient point. What's the point for the origin? 0, 0. And then this graph, and this is gonna seem kind of silly, but your points on that graph would be x, comma, x squared plus 2x plus 7. Do you get what I'm saying there? Like you plug in x and what you get back is whatever that is. That's how graphs work. Do you get that, right? Like you plug something in, you get whatever that is back. All right. Find the line with the minimum slope. That means you need to write an equation for slope. I would use m for slope just because typically that's what we use. Oh, no, it's just going to be whatever it comes out to. All right. So if you slope these 2 points, y2 minus y1, well, that's going to be this stuff minus 0, which would just be that stuff. I'm talking too much, I'm losing my voice. Over, and then it'll be x minus 0, which is just x. All right, critical points. Our derivative equals 0. So what rule do you need for this derivative? Quotient rule. How does quotient rule start? Times derivative of the top, 2x plus 2, minus, and then derivative of just x would be 1, and then it's over bottom square. Good, perfect. We actually don't need this part. We're just going to set the numerator equal to 0. So this is just going to be a whole big bunch of algebra. You distribute this x, that would be 2x squared plus 2x. I'm going to run out of room. Distribute the negative into here. That's just going to negate everything. Equals 0. Pretend I wrote equals 0. I just ran out of space because of the hole. All right. What can we put together there? That'll just be x squared. Good. Yeah, those cancel. So minus 7 equals 0. And there, that's not too bad. You'll get x squared equals 7. And x equals square root of 7. I think that one they just wrote positive square root of 7. I guess technically it could be plus or minus. All right. But anyway, that's the answer. You're just looking for the x value.